Okay, so this is day 12 of the worksheet. So first we have solve the following word problem, show all your work, explain your steps, be sure to show your graph and Desmos and discuss which portion of the graph is used for which question. So the question is, Harry and his friends are using a slingshot to launch water balloons around a field. The water balloon is 3.2 feet off the ground when it is launched and 29 at a 29-degree angle. Its initial velocity is 78 per second. So write the parametric equation that represents the situation. So first we have to understand the equations used for this the parametrics. So when we were trying to find x, which is like the distance, and then y, which is like the vertical, like horizontal and vertical, this is the equation. So x equals the magnitude times the t times cosine theta, and y equals half gt squared plus the magnitude times t sine theta plus h. So first we can do the x. So we know that the initial velocity or the magnitude of the initial velocity is 78 because it tells here. So initial velocity is 78. So you do x equals 78. T, we would keep this because that's our variable, and cosine here, and then the degrees is 29 because it says it is launched at a 29-degree angle. So this is our first one. The y, we would do negative half g is equal to like 9.8 meters per second squared, or like 32 meters. So we have 32. So we have negative half 32, which equals to negative 16. So we have negative 16. We keep this t squared as our variable, plus the magnitude of the velocity, which is 78 again, because it says initial velocity 78, plus 78 times t sine, and then the degrees again is theta because it says it is launched at a 29-degree angle, and then plus h, that would be our y, like the 0 would be like the ground level, but it says here the water balloon is 3.2 feet off the ground, so that would be our h. So we do it add plus 3.2. So to find this, these are our two parametric equations. So to find the time the balloon reaches its maximum height, what we do is we have to graph this y because that's our height, like our vertical height. So we graph this y equals negative 16 squared plus 78x times sine 29 plus 3.2. So inside of this t, we put the x and we graph it. So as we can see that this is our maximum point, negative 6.18 and 45.066. So that's our maximum. So and this is asking for its time. And so this would be our time and this would be our distance. So since it's asking for time and time can't be negative, we would just put 1.618 seconds because that is our maximum point of the y parametric equation. Next is time the balloon lands on the ground. How we find that is we use the same equation. So we use the same equation. That's the same graph. And what we do is we look at the y-intercept. So as you can see, the y-intercept is, the x-intercept, which is x-intercept. So it's 0.0610. So that's our y-intercept. And because it's the time, we would use, the seconds, so it'd be 0.061 seconds. And we use a y-intercept because we know that when x equals 0, that is when the ball returns to the ground. And so our x would be the seconds it took, because time is our x value. Okay, so next is maximum height of the balloon. So back to this question, we realized that the from here that our maximum is negative 1.618 comma 45.066. That's our maximum of the graph, and because it's a height, and we know that the y value is the height, so we know that this would be the height, that's the maximum height, so 45.066 meters. Next is height of the balloon 1 second after Harry and his friends launch it. So what we do is that we take this y equation, because this is where the height of the balloon, like the vertical thing, is. And so we have negative 16t squared plus 78t sine 29 plus 3.2. And because we're asked to find the 1 second, the height, we would replace the t with 1. So we get y equals negative 16 1 squared plus 78 1 sine 29 plus 3.2. When we put this in the calculator and when we solve for, we put t equals 1, we got y equals 64.56. So that would be our height after 1 second in feet. Next is the distance between the field away from Harry. First we have x equals 78t cosine 29. That was our x parametric equation. So distance down the field when the balloon lands. What we do is, because in the previous equation we know that this is when the time balloon that lands on the ground was 0.061, we would plug this into the x equation, because we're trying to find the distance, which is the x, like our x parametric equation, and it's the horizontal distance. So we replace the t with 0.061. So we get 78 0.061 cosine 29. So we got the x equals 3.56 feet. So the distance down the field when the balloon reaches its maximum height. So we know that our maximum height is when the time equals 1.618. That's again because of the maximum point of our y parametric equation right here. And so what we do is we replace this 1.618 with our x parametric equation, because we're trying to find the distance on the field. Again, it's the horizontal distance. So we use the x one, and we get that when we do replace this with 1.168, we get that the x equals 94.41 feet. So that would be our distance down the field when the balloon reaches its maximum height, 94.41. So next is the distance down the field 1 second after Harry launches it. Again, so we know that the t equals 1, and we know that we can use a x parametric equation because we're trying to find the distance down the field, so our horizontal. So, and we replace the t with 1, so we get x equals 78 1 cosine 29. When we simplify, we get 58.35. So that is the distance in feet down the field 1 second after Harry and his friends launch it. Okay, and that was day number 12.